Well, good morning, everyone. Welcome to the most exciting topic in programming, which is testing. Now, this was marked as an intermediate talk, but I want to be clear about one thing. The reason I marked it that way, it's actually a beginner testing talk, but historically I found that Flutter developers, they get in, they start working with Flutter for like 6 months or a year before they even start looking at tests. So I find that often people get started with testing once they're already an intermediate Flutter developer. So that's why it's marked as such. For those of you that don't know me, my name is Matt Carroll. I'm a former member of the Flutter team. And for the past 4 years, I've been working as a contract developer, consultant, educator, all those things. I also work on and maintain many open source packages for Flutter and Dart. What we're going to do today over the next 40 minutes or so is first, I'm going to start by dispelling a couple of common myths about testing, at least as I see it. I think if you want to be an effective tester, it begins with how you frame why you're testing and what you're testing. And then we're going to take a survey of the tools that are available to us as Dart and Flutter developers. We'll look at how to declare test, group test, run test, these kinds of things. And I'll sprinkle some life advice through those as well about how to make your life a little bit easier. So let's start with those common myths. The first one I hear a lot and have heard for many years in many different languages is that the idea is that tests somehow check correctness. And unfortunately, the name leads to that conclusion, right? Think about tests in school. It's like, are you right or are you wrong? But that's really not the right way to look at tests. They don't have any concept of correctness at all. In fact, what tests really do is they lock down your code and they stop the behavior from drifting someplace other than what you originally intended. So let me just give you a couple metaphors. Let's start with the idea of riding a bike to and from work. You ride your bike to work, you ride your bike home. Do you just drop it on the lawn and then go inside? No, you lock it up. And why do you lock your bike up? It's so that when you get up the next morning, that bike is exactly where you left it the night before. This is what tests are for. You make something work, you've verified it, you've decided it's correct, you don't want it to change from that point forward. You write a test, and if anybody ever alters that behavior for any reason, that test is going to fail and now it's got your attention. It's almost like also having an alarm on that lock on your bike. But a second metaphor, if it helps, you can also think about it like a ship or a boat in the ocean. If you put that boat somewhere and you want it to stay there, you need to tie it up. You can think of the other developers on your team. You can think of the product team, the design team as waves, as this current that's kind of suggesting your code behavior in one direction or another. If you don't tie it up, it's gonna move when you don't expect it to. And we call those things bugs. The second myth is that you should strive for 100% test coverage. Now, this one's probably a bit more controversial. There's strong kind of opinions on both sides of this. But if what you're looking at is an engineering problem when you write tests, it's difficult to make the argument that this number of 100% means something unique and special. And I'll make a few arguments to this point. I think you should choose your tests, what you test and how you test it based on a cost-benefit analysis. And this can be different for any given feature, any given technology. It's going to cost you something to write it, it's going to cost you something to maintain it, and it's going to deliver some kind of value in the end result. So I think any of us who have been in this world for long enough, we understand that some code is exponentially more difficult to test than others. One common place to find this is any given integration. Integration with Bluetooth, integration with user location services, integration with payment systems. You can, if you try hard enough, you can write automated tests for those things. You might have to fake all of Stripe to do it, but you can fake it. But is it worth your time? Most of us charge a decent amount for our labor. It costs a business quite a lot for us to fake all of Stripe or fake user location services or fake the Bluetooth radio. So start by recognizing that not all tests cost the same to your business. Second, something that I think developers often forget is that we as developers, along with our QA teams, we are constantly running our app. So let me give you kind of the reductio ad absurdum view of this idea of testing through use. Let's imagine that your app has one form of login. You don't write any tests for login. Is that actually a problem? Well, every developer on your team is logging in every time they build and deploy the app. Every member of your QA team is logging in every time they run the app. How many minutes could you possibly go after breaking login before someone finds it and fixes it? The answer is not many in most cases. So there are things that even if you don't have a human test script, they are being verified constantly. So how much value are you actually going to get out of testing that? Again, what does it cost your business to do it versus what is the value in terms of signaling failures? Also, we as humans tend to think 100% means full, means complete, means done. 100% code coverage does not mean your app is fully tested. Apps that claim 100% code coverage, they still have bug reports. So unless we're saying that someone intended to create the bug, something wasn't tested. So this idea of 100, it means something technically, but don't let it trigger that psychology that says that means complete. And if you know it's not complete, it begs the question, well, why not 98%? Why not 102%? What's special about this number other than human psychology? And finally, there are some bad incentives here. And I'd like to detour for just a moment to a story from a number of years ago with a team that I was on. We had a lot of bugs, and most people on the team couldn't seem to get the bugs under control. Management was getting involved. It was a problem. Now, I was a prolific test writer at that time. And this was before I was a Flutter developer. This was back in the Android days. But management came in and they said, listen, from now on, we're going to achieve 25%, speaking of arbitrary numbers, 25% code coverage from this point forward. And I think they even tied bonuses to it. You can make money if you wrote more tests. And I went to management. I said, listen, I write more tests than anybody on this team, but this is going to be a mistake. You're creating incentives here that aren't going to turn out well. And management was like, well, we've got bugs. What are we going to do? So within 2 weeks, I noticed in the code, this is going to be some pseudocode, but I noticed a bunch of things like this appearing in the code base. There were dozens and then hundreds of tests that were setting a property and then verifying the property was set. And I'm not saying there's absolutely zero value to this. I'm just saying it's pretty darn close. And what we weren't verifying with any of these tests was anything that actually mattered to the user, the customer, the person paying the bills. So this was a developer who did what management said. They were increasing the code coverage as a percentage, was probably getting a bonus for doing it. And this is where you end up. Did we actually solve any bugs doing this? I doubt it. And if we did, those bugs were trivial. What's more, if any of these setters weren't working, you could still discover that if you were testing something relevant that internally used the fact that you can set a property. Now, was this some intern that did this or some junior developer who just didn't know better? This was the tech lead for the whole app team. This is what incentives do. So be careful with your testing incentives. Now, that said, despite my opinion about chasing a test coverage amount, tests are incredibly valuable. They can save you a lot of headaches. And so you should write a lot of tests. And the question then becomes, what tools do you have? How should you approach it? So we're going to take a really quick run, a journey through the 4 major tools that are available to each and every one of us as a Dart and Flutter developers. We're going to start with Dart tests. So these are tests. So if you're writing a Dart CLI app, if you're writing a Dart server-side app, if you have code in your Flutter app that simply doesn't care about Flutter, these are business rules or something like that, you can write what I would call Dart tests. This is the test package that comes with the Dart programming language. If you want to write these tests, you'll create a test directory in your project, and you will create files that end with _test. That's a naming convention that's understood by the Dart and the Flutter tool, saying, these are tests, please capture these when I execute all of my tests. In terms of what a test looks like, a regular Dart test, in that file, in that Dart file, you'll create a main method. This is going to run like any other Dart application from main. And then for every test case as you see it, there's no hard rule about what constitutes a test case. Whatever you consider a test case, you call the test method, you give it a name for your test, and you give it the implementation of that test as a callback. If anything goes wrong in that callback, it will trigger a failure in that test, which will be reported to you by the test runner. You can also group tests. Now, there are a few implications when you group tests, but honestly, the most common one is that you want to be able to run some tests at the same time without running all the others. So what the group does is it takes the name of the group and it puts it in front of the name of the test. So when we actually run this, we're going to end up with 2 test cases. The name of the first test case, the full name, is proof that my thing does something, and the full name of the second test is proof that my thing does another thing. Why is that relevant? You can run all tests with the words proof that, which will then run only what's in this group and no other group, assuming that name is unique. Now let's talk about running tests. I'm going to show both the Dart and Flutter version here because it's exactly the same from a command line perspective. Once you define one or more tests in one or more test files, you can run all the tests in your project by going to the command line and saying Dart test. It will find everything in that test directory with _test. It will run them as tests, report the results to you. In a Flutter app, exact same thing, except you say Flutter test. If you want to test just what's in one file, you can specify the path to the file. So Dart test, path to the file, Flutter test, path to the file. If you want to run all tests that match a partial name, this is partial, not the whole name, you can say Dart test, pass the parameter plain name, and then whatever partial string you want to match. So in the earlier example of the group, if we just had quote my or proof that, we would end up running all the tests in that group and nothing else. Now, I mentioned this, or I applied this before, but to be clear, in a Dart test, you cannot run Flutter code. Generally speaking, you can't reference anything that's in the Flutter package, so no widgets, no elements, no render objects, no focus nodes, no semantics, none of that stuff. But you can run asynchronous I/O code. So not just async, but asynchronous I/O code. And I point that out here because you can't do this in widget tests. So widget tests will be next. But in a Dart test, if you should never do this, but if you wanted to do this, in a Dart test, you could talk to a local database, load data from it, and send it to your server. You have full access to the system, to I/O, to asynchronous behaviors. And this is unique to Dart tests versus widget tests. Which brings us to widget tests. This is where we begin to enter the world of testing with Flutter. So the name widget test is a bit deceptive. It might make you think you're testing a widget, and that really isn't the case. Instead, you should think of widget tests like this. You have your test suite, and then when you run a widget test, there's like this fake, virtual, almost ghost-like version of Flutter that's running invisible, and you're sending commands, you're verifying things in the widget tree. There's this whole fake version of Flutter that's running. It can do generally whatever you expect Flutter to do in an app, again, minus that asynchronous I/O behavior. So here's how you define a widget test. It's very similar to a Dart test. I've highlighted the differences. Instead of calling test, you call test widgets. Still going to pass a name. And then your callback signature is a little bit different. You're receiving this thing of type widget tester. If you ever see it called tester, that's just historically a common name for it. The type, the class name is widget tester. And that's what gives you the connection to that fake version of Flutter. If you want to start messing with the widget tree, that's how you do it, through the tester. And you're also going to make these async because every time you talk to the fake version of Flutter, it's going to be an asynchronous operation. So in general, you're never going to have a synchronous version of a widget test. Now, grouping and running works exactly like what you saw before. There's literally nothing new there. And now let's look at, like, canonically, in the average case, what is the structure of a widget test? Nominally, you're going to see three things in a typical test. Set up your widget tree, simulate a user interaction, verify a result. Okay, set up the widget tree, simulate a user interaction, verify a result. And we'll talk about each of the pieces involved with that. You'll notice in the top call here, you see tester.pump widget. This word pump, if you're not used to writing widget tests, this means nothing to you. It's kind of a weird term. What does that refer to? That's one of the most critical things to actually understand about widget tests, is what it means to pump. So let's dive a little bit into that. You may or may not know this as a Flutter developer, but every frame of your app, 60 times a second, 90 times a second, 120 times a second, you're running a pipeline. And that pipeline takes a series of actions. Collects user input, builds trees. That means your widget tree, render tree, element tree, semantics tree, focus tree. Runs layout, which is the size and location of every render object on the screen. Paint accumulates graphics commands. Those graphics commands are turned into a layer structure in what's called the compositing phase. And then finally, any animation that's running runs its update for the next frame. For you, this happens automatically. Again, every frame, based on your device 60 to 120 times per second. But I told you the version of Flutter that runs in a widget test is like a fake version. And the primary place that it's fake is in the passage of time. And this pipeline is fundamentally tied to the passage of time. So what does it mean to pump in a widget test? It means execute that whole pipeline exactly one time. And then your test can continue verifying or altering whatever it wants. So that first part that you saw in the previous slide where I said set up your widget tree with the same pump widget. This method is doing two things. It's taking your initial desire for a widget tree, which often will begin with a material app. This is like what you send to run app when you run your production app. And then it says run the pipeline one time. That first pipeline run takes your, in this case, material app, expands, builds the whole widget tree, builds the element tree, the render tree, runs layout, runs paint. So it gives you that first frame of a result, which you can then investigate, you can inspect pieces of it, or you can begin again simulating a user interaction from that point forward. Now, that is not the only time that you need to pump the pipeline or pump frames. Let's say that you simulate a user gesture, we simulate a tap. The reason you did that is probably because that tap is supposed to alter something else on the screen, but that means a change to the widget tree. You need to rebuild your tree. You need to update your render objects. So you need to pump. And ideally, hopefully you can just pump one frame and that will bring you up to date and then you can verify your results. Sometimes you might need to pump multiple frames. Now these tend to be unique situations. Sometimes you've done something here in terms of callbacks, end of frame callbacks that maybe you didn't mean to, so you should inspect it. But there are times where legitimately you have no choice but to pump 2 or 3 frames to get the result from the user interaction that you expect. And so I want you to know it's totally fine to call that a few times in a row. Sometimes it's necessary. It's not a big deal. Boom. It's good. So the question is it the same as pump and settle? And that is the next slide. So it is different. There's this method called pump and settle, which means essentially, as long as there is at least one animation or one timer that is running, Flutter is going to keep pumping these frames for you. It's going to call pump, 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 pump. That might sound very convenient. At times it is. At times it's unavoidable. But pump and settle is also inherently dangerous. And to kind of demonstrate why, I want you to tell me when this animation is over.
Yep.
It's not done yet?
Yes.
All right. Obviously, this thing's never going to end. This is what we call an indeterminate animation. It may never stop. And in fact, remember I said earlier that you can't do any asynchronous I/O in a widget test? You know those images where you show a loader until it's loaded? That image ain't loading. Okay? So these indeterminate loading indicators actually have a tendency to appear all sorts of places in your widget test where they'll never end. Now, there are strategies to mitigate that. You can have a global property that says, like, don't run these during a test. Okay, you can go add that if you want. But another solution is to just not pump and settle. Because you can pump one frame and nothing's going to complain. You'll just move the animation one frame and then you can move on with your test. But if you call pump and settle and this happens, your test will run, I don't know what the default is now, either 10 or 30 seconds, and then it'll blow up and say, we've timed out. We've never stopped having activity. So always use pump when you can. And my suggestion to you as someone who's written thousands of tests is that when you do need pump and settle, add a code comment saying why you need it, because someone's going to come back to that 6 months from now and they're going to have no idea why. And I'll make that point right now. This is a segment of a real test case from SuperEditor. SuperEditor is a document editing toolkit that my team built. It's an open source solution. But what we're testing here deals with dragging the document, scrolling it up and down. And we want to make sure that when you scroll all the way to the bottom and you keep scrolling on a mobile device, you get the over scroll. And then when you release, it goes back to the normal ending point. Well, we wrote that test as we thought it should look, and the test started failing. And it was this weird error. It was like dangling timer or something or other. It took us a bit of investigation, but we then realized, the same set of gestures that do the drag also contains a long press recognizer. And that long press recognizer in the gesture arena was registering a timer to see if it was actually a long press. And that's what was dangling. Nothing to do with the actual purpose of this test. So we add a pump and settle to let the timer expire, and then we finish our test and no more error. But had we not put this comment here, if anybody ever came to figure out, well, why do I need a pump and settle? They have no clue based on the context of this test why that was there. So it doesn't hurt you at all to add that comment, and it will save you some frustration in the future. All right, so let's talk about widget test finders. I told you how to set up the tree, told you how to refresh the tree, but what are you doing with it? If you're simulating a gesture or if you're verifying a result, you need to find something in the tree to verify. So just thinking back to the standard counter app, let's say you want to test the counter app, you need to find the floating action button to tap it, and you need to find the text to make sure the number incremented, let's say from 0 to 1. So finders, this term finder is actually a type, it's a class. Finders are used to find widgets in widget tests. Here's one example. So let's say we want to simulate a tap on what? Well, we say we want you to find some widget in the widget tree that has the text click me, and we want you to tap on that widget. Now, if that widget can't be found, you'll get an error. If there are multiples of them, you'll get an error. But if there's only supposed to be one, and you're sure it exists, you can say find by text, it'll find that widget, it'll tap on it. Here's the same thing using a different finding strategy, which is finding by key. So many of you will have times and places where you assign value keys, global keys, things like this to your widgets. You can use those keys to find that widget in a test. And in fact, one strategy is to define a bunch of public keys for this express purpose, so that between your test code and your source code, you have this contract of here are these keys, and they will be given to X, Y, and Z widgets so that tests can inspect the tree. Another way is by type. So if you have a widget type that's unique to a given screen, you can say find whatever widget is of type elevated button and tap that. And then these finders can also be used in expectations. So not only are they used with gestures that cause changes, but when you verify the result, you can say expect, pass a finder, and then pass a matcher. The matcher is the second argument. So in this case, we're saying, okay, go find whatever widget has text, welcome Matt. The matcher after that says we should find exactly one. So if there aren't any, our test fails right here. If there's 2, our test fails. If there's 3, our test fails. Only if there's exactly 1 does the test execution continue. And now this situation is a little more unique, but sometimes you need to check things that have no matcher. Now you can actually implement your own matchers, and it's often useful to do so if there's a check that repeats in your code. But let's say that we have a checkbox, and let's say there is no isChecked matcher. And actually, maybe there is one, maybe there isn't, I don't know. But let's pretend there's no isChecked matcher, and you want to make sure that your checkbox is checked. How can you do that directly yourself? Well, you start with the finder, just like before, but instead of passing it to something else to execute, we will execute it ourselves, which is what the evaluate method does. Evaluate says, okay, I've told you what to find. Now, for real, go find it. And that will come back with a collection of matches. In this case, we're implying that we know that there's exactly one match and we know exactly what it is. So from the matches, we get the first one. And then that match, I believe it's an element from the element tree, which then holds the widget associated with it. So we ask for the widget and we say, we know that this is a checkbox widget. So we typecast it. And from that point, we can then run the expectation that our checkbox widget, its value, which is true, false, or null. I guess we have a third state these days. It's either true, false, or null, but we say we expect that to be true because that means it's checked. So this is how you can manually verify property values on widgets. Now, it's also worth pointing out that the value of a widget doesn't necessarily tell you anything about the rendering, because what if the problem is in the element or the render object? That's a real concern. But just so you know, typically, when writing widget tests, verifying widget properties is deemed sufficient. That's where our industry is right now. If you want to verify more than that, there are other strategies and other tests. But ideally, if the widget property says is true, that thing should be rendering as checked. All right, simulating gestures. I won't go into a lot of detail here other than to mention that the widget tester object has a number of methods that simulate various gestures. We've already seen tap a few times. You can fling, you can drag, and in fact, you can even start an arbitrary gesture and end an arbitrary gesture. The challenge there is that it's up to you to decide what pointer events, what finger tracking events to pass in and what timestamp to give them. So in reality, it's actually really cumbersome to create a custom gesture in a test. You might be better off recording an actual user interaction than playing it back in a test. But typically tap, fling, and drag is plenty. I also included enter text. That's obviously not a gesture, but it is user input. And so it's all kind of the same thing. They pretend the user does something, verify a result. Now, enter text, depending on where you work with Flutter the most, mobile versus desktop, you might have different assumptions as to what that means. Enter text has nothing to do with physical keyboards. This, at a technical level, goes through what's called the IME, the Input Method Editor, and that's an operating system subsystem that sits between any keyboard and an application. So on your phone, you have that software keyboard you're up here tapping, right? Obviously, that's not a physical keyboard. That software keyboard talks to the IME, and the IME sends messages to your application. When you say enter text, you are pretending that you are the IME and you are delivering messages to the app. But you can simulate physical keyboard presses as well. Going back to my work on Super Editor, given it's a document editor, you can imagine we support all sorts of key combinations. What you see in front of you right now is the Flutter test code to simulate the shortcut on a Mac to move the caret to the beginning of a line of text. It's Command, Alt, left arrow. In Flutter, you can tell it to press down, you can tell it to release, or you can just send a key event, which means down and up. But once you're doing key combinations, you can't just say press that key, because keys have to remain pressed from the beginning to the end of the key combination. So in this case, we're saying, okay, press Command down, press Alt down, press the left arrow and release, then release Alt, then release Command. Obviously very verbose, and if you have a lot of key combinations, this stuff starts filling your tests. So a quick side note, my team created a package called Flutter Test Robots, where we've just accumulated a huge number of common key combinations. So we literally have a method, an extension method on Widget Tester called press Command Alt left arrow. We also have press Command Alt right arrow, press Control V, all these things. So if you happen to depend on a lot of key combinations, go check out that package. It might save you a lot of testing code. Now let's talk about the virtual Flutter configuration. Most of you are probably mobile developers, which means all day you're thinking about rectangles that look kind of like this. And then you go write a test, and suddenly you can't find something on screen that you're sure is on screen, or your layout's broken when on your actual phone you can see it and it's just fine. What's going on? Well, it wasn't a coincidence that you saw me represent this shape as the virtual version of Flutter, because the version of Flutter running in your widget tests thinks it's 2400 by 1800 pixels, meaning a landscape orientation. So your mobile app is being tested kind of like a browser or desktop app, and that may very well be the reason for the problems you're having with layout. Also, if you're really focused on iOS, you're working with all these iOS defaults and behaviors, you again might write a test. It doesn't do what you expected it to do. What's going on? Well, by default, every widget test thinks it's running on Android. This is largely just an accident of history, but also it has to think it's on some platform that happens to be Android. This also includes if you're writing tests for a desktop Linux app, it still thinks it's on Android. And in that virtual display, there's also a concept of device pixel ratio. This is different between all sorts of different devices. The modern iPhone and Android apps, I think, are at 3.0 physical pixels per logical pixel. But again, the number's different through history. The number's different from desktop to tablet to phones. If your widget test needs to pretty closely simulate an actual device, make sure you're accounting for the device pixel ratio as well. But all these things are configurable. So those are defaults, but you can change them. And here's an example of how to do that. In a widget test, there's a property called view on the widget tester. It has a property called physical size. You can set that to whatever you want. So you can go look up your iPhone 15 Max Pro or whatever it's called. You can say, what's the resolution? You can put it in there under physical size. You can update the device pixel ratio to match that device as well. And then another important point that's easily overlooked is there's this global property, which is a bunch of words, debug, default, target, platform, override. There's this global property that says what platform you're on. You want to make sure you set that to the one you care about. In this case, if we're emulating or simulating an iPhone, we're going to say, pretend our platform is iOS. And that's where all those adaptive things in your widget tree suddenly look like iOS instead of Android. And now you're getting the behavior that you've been testing all day on the real app. Also, I don't remember what the current state of this is, but I think historically these settings were global and persistent, which means you change them in test 1 and they would also apply to test 2, 3, 4, 5, 6. If that's still the case and you don't want that to happen, you can add what's called a teardown. A teardown is a callback that will run after your test. It'll run if your test passes. It'll run if your test fails. It always runs. So if you alter that view or you alter the platform, you can reset them in a teardown just like you see here. Now let's talk about golden tests. Technically, golden tests are widget tests, but in terms of writing them and maintaining them, it's such a night and day difference that I think it's worthy of its own name and its own consideration. Golden tests verify pixels instead of widget tree details. It takes some screenshot from before, it takes a present screenshot, compares them pixel for pixel. If they're not exactly the same, the test fails. So how do you define a golden test? This part here is a recommendation, not a requirement, but because, again, the maintenance of golden tests, it's so unique, I recommend keeping them separate from all of your otherwise regular widget tests. I always put them in a directory called test_goldens. But in there, you define a test file just like elsewhere. And then again, they are widget tests, so you define them like a widget test, but here's the one part where things get different is actually generating the golden screenshot. I'm going to run through each line here. It's kind of this is one of those things where it doesn't literally make sense that we're like expecting to generate a screenshot. So it's kind of one of these incantations you have to remember, but let's go through these lines here. First, you saw the call to expect. Expect takes a finder, it takes a matcher, and makes sure that the matcher is satisfied by the finder. It fails if it's not. Expect later is the same thing, except it has an asynchronous matcher. So still a finder, still a matcher, but the matcher can go do long-running stuff. Then we have our finder. So this is the question of what do you want to screenshot? Technically speaking, you can screenshot just a button or just a card, but in practice, it's most common to just screenshot the whole screen. And if that's the case, you can just find your Material app or your Cupertino app or whatever's at the top of the tree, and that will capture the whole rectangle. And then the next line is how you actually generate or compare the golden. And that's kind of the weird thing here. Depending on how you run this test, you're either generating the golden or you're comparing the golden, but it's the same code in both cases. So let's look at that. If you have yet to generate that golden file, or if you need to update it, you run Flutter test, but you pass this update goldens flag. And any golden test that is run during that test run, you're actually going to paint a new screenshot and save it to file. And this is also one of the reasons why I prefer to separate goldens from regular widget tests. I like to know what's being impacted by this when I update my goldens. But from there, once you've generated your golden files, you have these screenshots sitting in your file system, running those tests from that point forward will compare the existing screenshot to what just ran in your test. If there's 1 pixel of difference, that test is failing. And this is what the counter app looks like as a golden test. So I wasn't lying when I said that it really is landscape orientation when you're running a widget test. And the second weird thing, there's 2 more weird things here. One is, what are all these black squares doing here? This is the text in the app. When running a widget test, and this isn't just for goldens, when running any widget test, Flutter does not load the standard fonts. Flutter loads this special one called Ahem or Ahem, I don't know how to pronounce it, AHEM, okay? And what this font does is it replaces every character with a square. Now, I don't know if you've looked at regular English language, but every character is not a square. You know, like an L is really narrow. And so what does this do in practice? Layouts where you would never have a layout problem with any real English text Suddenly your layout's broken because your text is like a million characters, well, not characters, but a million pixels wide. So keep that in mind as well. If you see a weird failure on layout, make sure it's not due to the essentially the characters in the font being much larger than you expected. And then down in the lower right is the floating action button, and you'll notice there's this thick black border. That's where a shadow would normally be. To try to reduce the flakiness of these tests, Flutter turns shadows into solid colors. It's not perfect, but it's way less flaky than actually running a shadow algorithm. All right, and another thing to keep in mind is that different platforms are incompatible when generating Goldens. If you generate a screenshot on Mac, that same test with the same code will probably fail on Linux. You generate a Golden on Linux, it's going to fail on Windows. You need to make sure you generate on the same platform that you verify. And that gets tricky, especially when you're using something like GitHub CI runners to check on every PR. You have to figure out your own solution to that. We still lack a great one. Maybe we'll get something in the open source world sometime here soon to help out. Now let's talk about integration tests. So integration tests have the same APIs as widget tests. You're calling test widgets, you get the widget tester, you call those, you pump your widget tree, all those things. But the underlying test runner is different behind the scenes. The test runner for an integration test will actually build your whole app. It will deploy your app, your real app, your APK, your IPA, to a simulator, an emulator, or a physical device. So where this was a regular widget test, this is an integration test. Your test runner on your laptop, your host machine, is literally having a conversation with your app running on the device. And there's extra stuff put into your app on the device to have this back and forth conversation, but it is running for real on the operating system. And this means that now you're free to access a bunch of things you couldn't before. You can talk to your server, you can talk to a database. Now it's the real app. Of course, it takes way longer to run these tests because you're building your whole app. You know, what does it take you to build your app usually? That's what it takes for you to run your integration tests every time. If you want to use integration tests, the first thing you need to do is add this dependency to your pub spec. Now you'll notice that we're defining SDK as Flutter. This is part of Flutter. This isn't some extra package, but you do need to opt into using it. Then by convention, the Flutter tool understands this. There's a special directory where you create integration tests. It's integration_test. The Flutter tool, when you run test, will treat every one of these tests as integration tests. They will expect a device to be running. They will build the app. They will deploy it to that device. And again, running those tests is as easy as running Flutter tests. Just make sure you point Flutter at the integration test directory if that's what you want to run. All right, so some final thoughts. You might be wondering, which test tool should I use? We've looked at 4 test tools. Which do I use? I suggest that you think in terms of what runs the fastest, what has the simplest code in the test, and what has the least flakiness. Flakiness is when there's no problem, but the test says there is, or where there is a problem and the test says, no, everything's fine. You want to minimize that as much as possible. So here's the order that I tend to prefer things. If I can write a Dart test, I'll write a Dart test. They run the fastest. They're not the simplest, but they're pretty simple, and they're almost always accurate. If I can't make it a Dart test, I'll make it a widget test. Slower than Dart tests, but still very fast. They are more complicated than Dart tests on average, but not as complicated as integration tests, and they're almost always accurate. Then we get to Golden tests. These run slower than widget tests, but still pretty fast. They're extremely simple because the typical Golden test is pump a widget tree, take a screenshot, or it's pump a widget tree, do a gesture, take a screenshot. There's almost nothing in those tests, but they are extremely flaky. They fail for all sorts of reasons that have nothing to do with your code or the correctness of your code or having the behavior that you want in your code. And then finally is integration tests. In the big picture, integration tests are actually the most accurate representation of your real app possible. The problem is that they take forever to build and run. And especially when you're running these things on CI, that is now literally costing you money. What's more is that if you're talking to your server, you're talking to a database, any integration point with some other system, if that system fails, your test fails. So now that brings flakiness into it. The network cuts out for a moment, your test fails, your code is correct. but the test failed, and now you're figuring out what went wrong. So this is generally the order that I approach things, kind of from that cost-benefit analysis. Also, I highly recommend that you run your tests on CI for every PR. So quick recap. Tests aren't about correctness. They're about locking down desired behaviors. Avoid the 100% test coverage religion. If you have a good engineering reason, fine, but make sure you got one. Here are the tools available: Dart tests, widget tests, golden tests, integration tests. And you should optimize for speed of execution, code simplicity, and consistent results. And then real quick, just want to plug a couple things before we get out of here. First, every Wednesday at 12 p.m. Pacific, I co-host a public discussion about all things Flutter and Dart. This is on X/Twitter, so anybody's welcome to come listen. Also, anybody is welcome on stage. We'd love to, if we can bring half a dozen or a dozen people on stage to talk, we love to do that. We also occasionally have featured guests. Recently, we had Don Felker join us. We've had Remy join us in previous conversations. We've had members of the Flutter team join us. So I'd love to see you all there if you're interested. If you want to listen to older episodes, previous episodes, you can go to flutterspaces.com or look for the Flutter Spaces podcast. And finally, if your team needs any help, if you'd like some contract dev help or some consulting help, you can reach out to me at superdeclarative.com. So with that, thank you very much, and I hope you have fun testing.